Okay, guys. Let's try and move into the overlay discussion. So this discussion is in a lot of ways a continuation of the discussion we had previously. Okay, guys, here we go. So this discussion is in a lot of ways a continuation of the previous discussion where we were sort of saying, okay, can we get to app coexistence by sort of splitting the world up into sort of layers, because we're networking guys, that's how our brains are wired, and the ability to pass with light handoff between them. And this was just one example of how you might look at layering. There were a lot of discussions around that. This is not the one true example. But this conversation is about basically sort of an overlay layer, primarily because it wasn't, in the attempt to do this before, that happened during Lithium, it wasn't entirely clear that you needed a distinct overlay layer, at least not at the beginning. And I think there was some sense at the end that this might really make life less painful if there was actually an overlay layer where you could have someone who was in charge of the data path piece of the overlay and some well-defined way to program that with overlays dynamically, so that it basically, rather than having to manipulate the data path for overlays at every single layer in a pipeline, you could say, okay, I know I want this kind of behavior for things with this kind of a lookup key in terms of overlays. Tell the overlay layer, and then dealing with that when a packet gets there looking like that is the overlay layer's problem in the data path. Was kind of like the general idea in my mind. And as it turns out, Colin's put a lot of thought into this as well. And so we've mic'd him up, and away we'll go. And he had some interesting and even more colorful things to add about this than I do. So go ahead.
I'm just going to let you keep going for a bit, because I'll jump in when I think I have something to add. But no, I mean, essentially, the other talk, so the reason I'm here is because I somehow got signed up for another talk on network abstractions. And it's not that I don't have anything to say about network abstractions, but I didn't know why I was signed up for that, or where it came from, or who wanted me to talk about it. So, and the first thing I think of when I think of network abstractions is essentially recursive overlays. That's sort of, I mean, essentially, if you ask me what I think the one network abstraction that we should be using is, it's an overlay. And that's, in the history of networking, has been the only way that we've ever gotten abstraction out of our network, was overlays. And so I think the idea that you want to be able to support nested and recursively defined overlays inside of Open Daylight as a first-order construct, as sort of a way to move up and down the stack in terms of abstraction, is probably the right approach. But and I've thought more about it than that. But that's all. That's sort of why I'm here. Why the two rooms are sort of combined, and I think it ties into this. But I'll let you keep going. I don't know if that makes sense to you.
It makes sense to me. Does it make sense to everyone else?
And actually,
not to imply it doesn't make sense. It makes a lot of sense. But he's talked to me about this before.
And so I think that ties into the previous conversation in this room, which I think most of you were here for. But I was going to ask a question at the very end, which is, how do you make this recurse? Which is like, it's very logical to think about. I want to have an overlay at the top level that basically says, I want the following policy and the following service chains to apply at this overlay. It gets turned into an underlay packet. The underlay packet looks at it and says, well, on the physical underlay, I now have the following policies and the following service chains that want to apply in the underlay. And then that might turn in fact out to be an overlay again, right? And this is how we built our networks. And so being able to cascade down through that in exactly the ways that this sort of lays out, I think is the right set of approaches. So that's really why I'm here, and hopefully that helps. So
yeah.
And basically that's, I mean, beyond thinking about it, and so the question, and that's the only question I would ask about these layers, and maybe Ed, you can answer this, is sort of, how do you, do you imagine these three layers, this pipeline?
Or some other set of layers that
or some other set of pipeline. I mean, so I guess the only thing that I would say is that in general, the design goal I would start with is, you want the input of the last part of your block to be the same as the input to the first part of your block. Because if the input and the output are the same format, you can recurse. And you can insert and reorder. And if you don't do that, then you are stuck with one particular ordering of your layers, and you can't recurse. So that's pretty much, that was what I wanted to add. Yeah, that works. And I guess and I have a different dream that actually they're all instantiations of overlays, which is that policy is actually an overlay and SFC is actually an overlay. Which is to say that if you think about what SFC is an expansion of an edge in a graph between two endpoints into a series of nodes along that path. So it's really a translation from an overlay, which is the policy, or SFC, down into an underlay, which is another topology. And so I think these are all actually topologies.
Did I capture what you're looking for with recursion?
Yes.
Admittedly by looping.
And so I guess my take is actually these are all special instances of topology translators. And so it's useful to call them out because if there are special instances of them that are useful, call them out. But in practice, I think they're all topology translators. And in that sense, you can rearrange them. So you could have policy, overlay, SFC, policy, overlay. And there's no reason, and if that's not useful, maybe that's adding more complexity and generalizing too much. But certainly, that's my dream is that these are all just topology translators, which is, and that might not help understanding, but I think that it would make the most flexible network abstraction. And that's sort of, as I've thought about it and talked, David Bainbridge, who's not here, and it would be great if he was, and I talked about this when we were talking about Nick a long time ago, which is, how do you chain these things? And you obviously need to bring more information as you fall down these chains, which is you can't just expand, right? Like, you have to somehow put in extra annotations as you expand things down, because essentially, and this is actually really, abstraction is the destruction of information. Which is the destruction of information, right? Because when you aggregate things, there were boundaries that you can no longer see. And so when you go back down through abstractions, you by definition have to create information. And creating information is you need to pull things in from the side. So you're going to need to have extra context on the side as you go up and down through these things. Anyway, that's for unprepared remarks, random musings of Colin's brain in terms of what I think of as network abstractions and how they fit into this. And I think they're converging on the same set of ideas. And the Lisp people will tell us that this is Lisp and we've reinvented it for the 17th time. So
that's next session. Yeah, no, I'm reminded, your comment about overlays reminds me always of, I had a really, really dear colleague who was an IEEE guy and used to joke, to the extent that I have a god, it is layering. And so when you say I sub-overlays into that when you were saying that. So, I mean, this is the idea is, can we work out a way to have a dynamically programmable overlay layer that is useful to a wide variety of applications? I know we had some question about L2 and L3 and routers and switches, and in some sense, my gut feeling is, and I'm willing to be persuaded that I'm wrong here, but my gut feeling is that by the time you get down to the data plane, that's entirely a matter of having dynamically programmed overlays for that kind of stuff into the overlay system. And then it's just sitting here going, I have an IP address, or I have a MAC, and therefore I use that as a key to do a lookup, and I get back the overlay topology that I should be working with. In fact, this might be a good place for a slightly different picture. I'll talk a little bit about how I think about it. Doesn't make it the right way, but hopefully it starts the conversation, which is I tend to think of it as sort of a, you have some kind of a key, which could be a destination IP, it could be an SSH header, it could be all kinds of things that maps to, I should really have made this a square. One moment. So you have a key that maps to, that is not what I wanted. Sorry. Kill with maximum prejudice. There we go. Cool. So I have a key, and that maps to some kind of an overlay topology. And apologies for not putting the directionality of the topology in. So that's kind of how I think about this in terms of dynamic overlays, because then I can program into this, for this key I want that overlay topology. And the overlay topology system can say, okay, when I get this key, I look up this overlay topology and I can figure out where I am in it and where I need to be going next from it, and take the right action in terms of putting things on the overlay. Do folks have other ways they like to think about this, or that might be interesting to think about this? Or my general inclination, as you saw from the last session, is to sort of start tossing mics into the crowd and see what comes out.
So I'm going to pause and wait for anybody to do this. Go ahead. Okay.
Pass the mic back. Careful to pass it through Abhijit.
So generally how we do our overlay is you could think of it as point to cloud. So everything's keyed off flow. So we don't have like a n squared mesh of destination-based, IP destination-based tunnels. We put the destination, because every packet has to have a destination, right? But we put that in the flow, so everything's keyed off flows. So from the outside looking in, it looks like point to cloud. So is this going to be able to do that? Can you make sure you address that so we have a similar pattern?
And by point to cloud, you mean point to group, basically? Like I point to, if there's...
So there's one tunnel interface on the switch, and
Yeah.
it can reach every single other switch because it's keyed off flow. Well, no, because if you put a destination IP address, like a remote IP address on the tunnel interface, that's where it goes. Right?
Yeah,
Therefore, you need, for every other switch, you end up with an n squared number of tunnels.
Yeah, I think what you're getting at
That's why
is,
it's point to cloud.
yeah, I think what you're really getting at is, so when you're saying what physical interface do I put this packet out? What's my output interface? There are kind of two ways to do it in OVS that I'm aware of. There may be more. One is that you actually peg up an interface for an actual tunnel. You say, this is the tunnel, this is the destination IP of the tunnel, this is the encap type of the tunnel, et cetera. The other one is you say, this is kind of a tunnelish thing as an interface, and I believe you specify the encap, but you've set with your flow the particular destination address of that tunnel. And so you only have to keep the one interface around, which is convenient in lots and lots of ways, and you let your flows set the destination IP. So rather than picking among a plethora of tunnels as outputs, you set the destination IP. This might, getting back to all the conversation about multicast, I'm not sure quite how you might handle this in the case of multicast, if you needed to put something out multiple tunnels if you're using that tactic. Okay. That's fine. That's fine. Don't want to rattle into that again. Yeah.
So I guess the way I've usually thought of this, and maybe this will be useful to people, maybe it won't, is that actually you start off with essentially what you called like the null overlay, which is basically all of the endpoints in the world, wired up to one node, which is your network. So everything that is attached to your network is attached to one node, and then every node in overlay topology expands to either doesn't expand or expands to an underlay topology. And so rather than having sort of a key points to an overlay, and then basically your path computations become, I find a path in the overlay topology, and that path includes a node that expands. I need to find a path in the underlay topology through that node, and you recurse.
I tend to think of it a little differently. It doesn't make the way you're thinking about it wrong, or maybe I'm mishearing you, because I tend to think about the topology as being the specific graph through the underlay that you wish to be on. And based upon that, you can figure out where you need to go next, rather than the entire underlay topology. Or did I misunderstand?
So I guess the way I think of it is, every well-connected component of an underlay becomes a node in the overlay. If you're this is one way to think of it. So if you imagine, so let's just get really concrete. I have 10 OpenFlow switches. They're all being controlled by one controller. I can aggregate them together into one node in overlay topology and say, the controller understands how to make this look like one node in a higher level topology. So I'm giving you a node, and whoever wants to use that node in a higher level topology can. At which point, if you have it, and maybe it speaks BGP, and so at that point, on behalf of its nodes. And so that then becomes, so your entire OpenFlow 10 switches become one node in an L3 BGP topology, where you can then do computation and maybe use PSEP to find routes. And so if PSEP finds a route through this node, it will then, it understands that this node is not actually a PSEP node that can be programmed. It's an OpenFlow node, and it gets expanded, and that gets handled by a driver, essentially, for that OpenFlow node. It finds a path through the OpenFlow network.
I think that you're just thinking in a more global sense, and I've been thinking a little bit further down into what do I put into the data path.
Well,
So that's possible, yeah.
At the end of the day, what this ends up resulting is it ends up resulting in at every single node you have a description of what kind of traffic you're matching on, and a next hop, right? And if that match and a next hop happens to happen on a meta node, then that becomes a series of matches and next hops through loads that are in the
When
underlay.
you get out of the level of flows, but for example, like if you're looking at something like SFC, you really do want to say, this is my SFC topology through the world, because that's the level at which you're dealing with, is the end-to-end topology. You'd like to be able to tell that to the overlay layer and have that come down into flows on the switch. Does that make sense?
So the way I've thought about SFC, and maybe this will help people, maybe it won't, and if just me and Ed talking to each other, please tell us to shut up. Both of us would rather other people talk. But the way I think about SFC and the way I've thought about it is SFC is an edge between a source and a destination, and it has a list of things which you should go through. I mean, right, it's a service chain. By definition, it's a list of things that are on a chain. And so when you expand that, it expands into, rather than being just an edge, it is a series of edges through points, where each node on that, where each vertex that you expand that edge into is a VNF, for lack of a better term, right? So if you have a service chain that says, I want to go through VNF1, VNF2, VNF3, when you go from a source to a destination, you take source, edge, destination into source, source, edge, VNF1, edge, VNF2, edge, VNF3. And that is now a problem that can be passed on to whatever understands where VNF1, VNF2, and VNF3 are, and actually find a path through that. And that might again recurse down into more topologies, which is in practice how we do, multi-layer pathfinding. And for instance, like this is what the optical electrical pathfinding people are doing. It's the same general idea.
So say something, please.
I'm not sure, but I think you made SFC sound a lot more complicated than it is. So SFC, strictly speaking, is just a simple overlay. It has a concept, if you will, of, to use the kind of the internet architecture terminology, locators and identifiers, whereas wherein service functions have identifiers and they're located behind switches, and the overlay is constructed between those switches. It's that simple. There's no recursion through the layers needed per se. Rather, as long as you know the mapping of service function to overlay, for lack of a better term, to tunnel router, because an overlay is fundamentally a form of tunnel, to a tunnel router, as long as you know the presence of a given service relative to its tunnel router, the overlay is constructed.
Sure. The point of the recursion is to hide the complexity. I mean, so right, at the end of the day, if you have a service chain, right, you have a source, a destination, and a series of points to go through, right? It's a series of waypoints. Sure. I mean, that is a service chain, right? And somebody needs to figure out how to get from the source to the first waypoint, to the second waypoint, to the third waypoint, to the last waypoint. And the fact that you can sort of recurse through this means that you can either punt that to the underlay network and say somebody else has solved that for me, or you can explicitly invoke somebody else if you wanted to, right? Does that make sense?
Yeah, I guess what I'm saying is in the model we've chosen, we don't punt to the underlay. We
actually directly compute the entire path?
No, we know the next hop. So think of it this way. If you think of a graph at each node in the graph,
yeah,
we know the next node required in the overlay, not the underlay.
Sure. And so that's
a fundamental thing that has to be understood.
And that's punting to the underlay, right? Which is to say, I have a tunnel. The tunnel has been set up, and the tunnel is an explicit way of punting to the underlay, right? It's saying I have something where it's somebody else's problem to figure out how to get where I'm going, and they've already done that for me, and it's a tunnel, right?
I'm not sure I'd characterize it that way.
I think that's Ed's discussion of whether we should have a tunneling model or a dynamic encapsulation model is a useful discussion to have, I think, because one buys you, the interface model buys you certain things downstream, like an implied destination, stuff like that. And a dynamic encapsulation has better scaling properties of that idea, but it also falls down when you apply features because the interface buys you, again, a feature path.
Just to add a little bit to the discussion, the first thing that hit me was, yes, you've got the right model, recursion, et cetera. Maybe to expand the thought process a little bit, even with SFC, if your functions cross data centers, you're going to be having to deal with an underlay somewhere. So when we think about this as a service provider, we imagine, planes, layers in a network abstraction, maybe implemented in a graph database of edges and nodes, but that you can see spans at layer 0 and know when someone buries a cow. You know where there's layer 2 above those spans that take circuits and create connections between Ethernet switches, et cetera. You see above the Ethernet switches places where you've decided to put routers or not put routers. Again, a different overlay. Above those routers, places where you've put in MPLS-TE tunnels, which is a different construct of where's your next hop that is an overlay that has an underlay, et cetera. If you do service function chaining, it's that list of things, and they couldn't be in one data center, multiple data centers, rerouted on the fly, et cetera. So we exactly have this model in terms of what we use to operate and what we visualize for the operations folks for troubleshooting, repair, doing root cause analysis, and probably a billion other different examples of using the topology to go up and down the layers, exactly as you said. So we need that, that kind of iterative and recursive topology or layers or whatever. That's it. +1.
Okay, and
+2.
and for the record, that's AT&T and Comcast.
Yeah. So I do actually want to ask one question, though, because absolutely you need multiple topologies, and that's why we have a multiple topology model to express this stuff. We're sort of thinking about, if I'm sitting here with a particular packet that I need to forward, and I'm trying to figure out what overlay it should be on now. Not sort of like, yes, you get globally recursive overlays as you go through the world topologically, but how do I figure out the next hop that it should be taking in terms of the next destination? So if I'm doing some kind of traffic engineering, et cetera. And I've been thinking about this a little more at that level, as opposed to, clearly, you're absolutely right, like multiple topologies, et cetera, et cetera. So I'm curious your thoughts in that vein, because I think everybody agrees multiple recursive topologies is exactly the way networks fucking work, right? It's just the nature of things. Does that make?
It does, but
Yeah.
I think by the very nature of, there's always an order to your layers.
Of course.
So if you have a packet and you fire the topmost rule, topmost layer, and if that doesn't have sufficient information to tell you flood to all ports or go out this port, then you go to the next layer and have it do each of their policy. And there's a specific ordering, someone's first and someone's second for each layer.
Agreed.
That.
Yeah. And eventually you get to the end of what you can actually do. The end of your ability to recurse at this particular node in the system.
Correct.
And now you know what topology you're on.
And then there would have been a default. If you get to the bottom, there's always going to be a default, which could be block, it could be flood, could be always go up the left, the lower IP address.
Yeah. So I mean,
right?
if you're falling through and you have some notion overlay-wise of, okay, I hit down to the point where I'm looking at L3, I'm looking at an IP header, and that tells me I should get onto a tunnel that goes over there. You don't bother looking down at the MAC address, right? You know there. But if you don't find something for that thing, you say, okay, maybe I'm doing L2
gets
tunneling.
back at that. It has to,
Yeah.
your start and end part have to be the same so that you can recurse, right? So
Yep.
Same idea, right?
Yep. Agreed.
Right,
Yep.
okay. You get the next thing.
There are two of them now. They've gotten the message that we talk a lot.
So, very interesting discussion. I'm trying to understand how this changes what we're doing now. Because we do have topologies, and we have layered topologies now. What would your model change?
That is a fabulous question, right? So there's the really high level version, and then there's the way it kind of works in my head. And I'm trying to keep those separate. So the high level version is that rather than having NetVert handle the problem of where things are going with an overlay, in terms of putting things on an overlay, or having group-based policy put things on an overlay, or having SFC put things on an overlay, my notion is that they would basically say, hey, this is what I'm going to tell the overlay, whatever the overlay system is. For example, if you know this MAC address goes over there, you say, hey, here's the MAC address, here's the information about your going overlay system. Now it's your problem in the stack to deal with it. And I'm not going to have to go munge flows and deal with all that stuff. And likewise, then you also don't have to deal with same for SSC and same for everyone else. You don't have to sort of have everybody creating their own tunnel interface to make sure it's there and everything else. You have one piece of the data path that's responsible for that gets programmed by other layers, policy, netvert, SFC, such that when you actually get to that handoff point in the pipeline, you have something handling that overlay. And rather than having netvert or rather than having SFC deal with, do I want to have tunnels? I'm using set tunnel dest IP v4. Are there now 3 interfaces because there are 3 different people in the pipeline who could be outputs for this? Do we have all this other different stuff going on? You have one. And you have one way to dynamically manage the change that you're dealing with. And part of where I think we saw this, do we have... Let me kind of give a concrete example. Let me give a really concrete example. Oh, please, sure.
So that people know, the reason we're making you hand mics is because we're recording it for everything for other people. And so the YouTube video that we post will contain whoever is talking when they're mic'd, and will contain silence when you talk without a mic. Because the mics that we're recording from do not pick up the ambient noise, even if your ears do.
So the question there, Ed, would be is that if you wanted to know all the layer knowledge, right? For example, if you pick any router or any of the current devices, of course there is L2 topologies, L3 topologies, probably MPLS or whatever the things. Various topologies are there, right? But if we start centralizing everything into one location, which is quite possible to do, I mean, it kind of becomes, maybe it would work in an SDN model because it's all centralized model, but in general, essentially now you have to munge everything through one thing, and the whole notion of decouple, layered, and all that kind of stuff sort of goes away, right?
Well, I mean, the thing is, this is just for dealing with that overlay piece, and I'll sort of give you an example of where we hit difficulties, not insurmountable, but things where the world was harder than we wanted it to be when looking at this just for the handoff between GPP and SFC. So you have this policy thing, a packet comes in, and it gets handed off to a service function chain. So you hit policy, you get handed off to a service function chain. The service function chain's only role in life is to tunnel this through the service function chain, the service functions. And it gets to the end of the service function chain. And so you're at the end of the service function chain, you're popping off the end, and the question is, okay, now what, right? So there are circumstances in which what you need to do is to tunnel this back to the place that that particular VM has dynamically been deployed to, which is being managed, in this particular case, by group-based policy because it's the one that's handling the neutron calls. So you get to the end, and you should be tunneled back to some place that's being managed by someone who's not SSC, right? And so now you either have to replicate all your tunneling information across 2 people who are both managing overlays when you actually start chaining together in the global sense, not the local and the pipeline sense. Or the simple thing to do is to put somebody in charge of dealing with these lookups for where your overlays are, so that when you get to that end of that chain on SFC, you hand off to the overlay layer. It's the same overlay layer that group-based policy told how to, when you have a destination IP like this, this is where you tunnel it to and how. So group-based policy, if it falls off the policy, doesn't use SSC at all, it's the same mechanism. But when you get to the end of an SFC chain, you're also using the same mechanism. And so this actually makes it much simpler when you have things in the global sense, like across switches and routers and across tunnels, that are pipelining together across the network, not the local in the flow table sense. Go ahead, Keith.
Technology. So let's just say that I'm requesting an overlay as a service, right?
Yep.
I have an endpoint I want to get to. I have a node from inventory that I want to send a packet to. And so I'm going to request this overlay function to get it there,
Yep.
right? Is your vision that generically, so I've got a VM on OVS 1, and VM 2 happens to be on OVS 1 as well. And yeah, well, we talked about this. So
No, we did.
if I'm going to generically ask for this service, are you going to handle the local case, knowing that we can't tunnel locally? Can I just generically, or do I have to be, I don't want to have topology awareness. If I'm going to use this service, I don't want to be topology aware. I just want to say, hey, here's an endpoint. I happen to know the node in the network it lives on by IP address. handle it in the loop. I never have to check if it's local. Okay, you're going to deal with that?
Can I ask a question, which is how have we gotten ourselves with our head in a noose to the point at which we're somehow a packet on a switch that we didn't we somehow missed the fact that we're going to get tunneled to the same switch. Like, it seems like that was information we could have had much earlier when we were chaining this all together and avoided, right?
No.
No.
No, you cannot.
No.
Just because a VM ends up on a particular vSwitch doesn't mean its IP address has to be. Sorry. Just because a VM ends up on a vSwitch doesn't mean it necessarily has to be out of some namespace or number space that is preordained for that switch, right? It could be a totally foreign IP address that has no correlation. VM1 could be numbered out of some namespace that's totally different than VM3, right? It doesn't have to follow a subnet model is what I'm saying.
I think there's actually a different thing that Colin was getting at. So, but here's the thing, Colin. The problem comes up when you start having multiple domains of things that you're doing. This actually gets to part of what was motivating the thinking about layers between policy and SSC, which is I could have something where I've got both VMs on the same box. And I've got group-based policy taking the neutron calls to handle basic setup. And you come in and you say, as a matter of policy, traffic between these two groups of endpoints where one thing is in one pinpoint, one's in another, it should pass through a service function chain. Could absolutely happen. And that service function chain takes your packet off the box and then back around it in, right? So you can have this situation where even though the packet's eventual delivery is local, its intermediate delivery is not local. And go ahead, Keith.
Isn't exactly what I was asking. That's a use case where it pops up, where you're going to have to go off and on. The whole point I thought of this was to create a service that we could leverage.
Yeah, no.
That as generically as a service is, I shouldn't have to know whether this IP address is me locally or, and that was what I was getting at. So I can have a generic pattern, very simple. There are cases, the chaining one's an example, where you go out and come back in where you wouldn't, you'd switch local.
I mean, I wasn't quite to your question yet, Keith. I was basically to Colin's question of how did we wind up in this place? And the answer is because there are these things that happen in the world where sometimes even though your eventual delivery is local, your intermediate delivery is not local.
No, that wasn't, so maybe I'm misunderstanding Keith's question because, or, let's table this because I think I'm confused as to how what Keith said. I think there's a lot of confusion, and we can either try and dive into it. The other thing is I think we're technically 5 minutes over time.
We are over time.
So I think that there's. Let's table that question, and we can pick it up on the mailing list because I'm confused about. I'm more confused based on how you answered me and you answered me than I was when I started.
Okay. So yeah, we are heading up. We are 5 minutes into the break. Apologies. So. The next session, okay.
We're 5 minutes into the next session, which is going on in a bunch of places.
Yeah, so we're 5 minutes into the next session. The next session, I believe in this room, is looking at one, certainly not the only, and the whole point of having the pipelining is that you can actually sub in multiple different ways of dealing with an overlay layer. But one way of dealing with, or other layers as well, one way of dealing with an overlay layer would be with Lisp, because that gives you a nice mapping between keys and overlay topologies. Where you can make these kinds of requests that deal with some of these interesting things that happen with things that end up looping out and back and passing between various domains in terms of the tunnels and overlay topologies you deal with. Uh-huh.
I wanted to ask that question. If we go to this overlay.
Uh-huh. Sure.
So if we go to this overlay model with this key, I was assuming you were probably going to use Lisp there in the back to do this.
I've been honest about my feelings.
Yeah, well, that's right. That's what I'm trying. You know, and from us coming from the network world, you know, we can get the mappings through Neutron. We have the MAC address mappings. We don't need this Lisp. So if we go to this model, are we stuck now? Or I shouldn't say we're stuck, but are we now forced to use Lisp or something else?
The intention is not to be.
service?
The intention is not to be forced to use any particular implementation of the overlay layer. You know, and if you're the only thing in the universe and you're managing, and you don't do pass off to other things in the pipeline, then you can manage your own overlays. It just turns out when you have passing off to other people who might go off box and then need to come back on to a particular box, that being able to have everybody have access to the same table of overlays that can be dynamically programmed ends up being a massive simplification.
If you fit into it. right? I mean,
Well, I mean, if you're in a position where you're wanting to hand off from, say, some layer to SSC and then be able to do your delivery on the other end, I would imagine if Netver were to hand off to SSC, you would have exactly the same problem we ran into here, and you need to find some way of dealing with it. And I'm not saying it can't be done in a different way. It can. It was just really hard.
Logically, all this, I mean, so everybody in this, mostly, how many of these people in the room are programming in Java? Okay, and how many people know what the service registry is in OSGI? Okay, so the service registry in OSGI is basically just a way of saying, hey, if you're looking for something that implements interface X, here's a way to look up people that are offering interface X. And really what the overlay manager is providing is logically a service registry where instead of looking up X, you're really asking, hey, when I want to try and reach somebody, some other well-named thing from here, here is a tag to stick on that will get you there. It's a service registry for endpoints in contexts, where the context is where I am now, and and the service that I'm looking for is an endpoint. And it's not a perfect analogy, but it's a pretty decent one for what's going on that might make sense. And so in that sense, it really is sort of, it is asking, can we generalize what everybody is doing in a way that we could share that information? The same way that rather than having like 17 different people implement 17 different interfaces for, say, like, I don't know, topology or ARP. No, let me like having the 17 different people implement, like, say, we're trying to convert from like CSV to Excel. And rather than having 17 different people implement 17 different interfaces for CSV to Excel documents, we have an interface for CSV to Excel documents, so anybody can reuse the other ones. And so this is really just asking, could we invent a simple interface to describe what an overlay does, which is it basically gives you a way to take a context and a destination to some kind of action, and do that once, so that way you can pick whatever your overlay is right in context and look it up and use it. And that's a good idea on the face of it. Trying to actually get it to work in practice is going to be interesting, but I think that's the whole point.
Yeah, the whole point is to sort of start moving in that direction, because everything has corners as you move forward, right? As you go through things, everything ends up having corners. Cool. So thank you, guys. I appreciate it. And for those of you who'd like to hang around to sort of talk a little bit about the possibility of doing some of this with Lisp, not the only way it could be done, but certainly an attractive one, because it maps very well to the problem space. We'll be doing that here. Let's take 5 and come back so folks can use the restroom. Lithium, it wasn't entirely clear that you needed a distinct overlay layer, at least not at the beginning. And I think there was some sense at the end that this might really make life less painful if there was actually an overlay layer where you could have someone who was in charge of the data path piece of the overlay and some well-defined way to program that with overlays dynamically, so that it basically, rather than having to manipulate the data path for overlays at every single layer in a pipeline, you could say, okay, I know I want this kind of behavior for things with this kind of a lookup key in terms of overlays. Tell the overlay layer, and then dealing with that when a packet gets there looking like that is the overlay layer's problem in the data path. Was kind of like the general idea in my mind. And as it turns out, Colin's put a lot of thought into this as well. And so we've mic'd him up, and away we'll go.
We'll have the following policies and the following service chains that won't apply in the underlay. And then that might turn out to be an overlay again, right? And this is how we built our networks. And so being able to cascade down through that in exactly the ways that this sort of lays out, I think is the right set of approaches. So that's really why I'm here, and hopefully that helps. So
yeah.
And basically that's, beyond thinking about it, and so the question, and that's the only question I would ask about these layers, and maybe Ed, you can answer this, is sort of, how do you, do you imagine these three layers, this pipeline?
Or some other set of layers that
or some
turns out to be
set of
smarter.
pipeline. So I guess the only thing that I would say is that in general, the design goal I would start with is you want the input of the last part of your block to be the same as the input to the first part of your block. Because if the input and the output are the same format, you can recurse.
No,
and you can insert and reorder. And if you don't do that, then...
Okay, guys. Let's try and move into the overlay discussion. So this discussion is in a lot of ways a continuation of the discussion we had previously. Okay, guys, here we go. So this discussion is in a lot of ways a continuation of the previous discussion, where we were sort of saying, okay, can we get to app coexistence by sort of splitting the world up into sort of layers, because we're networking guys, that's how our brains are wired, and the ability to pass with light handoff between them. And this was just one example of how you might look at layering. There were a lot of discussions around that. This is not the one true example. But this conversation is about basically sort of an overlay layer, primarily because it wasn't, in the attempt to do this before, that happened during, and he had some interesting and even more colorful things to add about this than I do. So go ahead.
I'm just going to let you keep going for a bit because I'll jump in when I think I have something to add. But no, I mean, essentially the other talk, so the reason I'm here is because I somehow got signed up for another talk on network abstractions. And it's not that I don't have anything to say about network abstractions, but I didn't know why I was signed up for that or where it came from or who wanted me to talk about it. So, and the first thing I think of when I think of network abstractions is essentially recursive overlays. That's sort of, I mean, essentially, if you ask me what I think the one network abstraction that we should be using is, it's an overlay. And that's, in the history of networking, has been the only way that we've ever gotten abstraction out of our network was overlays. And so I think the idea that you want to be able to support nested and recursively defined overlays inside of Open Daylight as a first order construct as sort of a way to move up and down the stack in terms of abstraction is probably the right approach. But you know, and I've thought more about it than that, but that's all. That's sort of why I'm here, why the two rooms are sort of combined, and I think it ties into this. But I'll let you keep going. I don't know if that makes sense to you.
It makes sense to me. Does it make sense to everyone else?
And
Which is
actually,
not to imply it doesn't make sense. It makes a lot of sense, but he's talked to me about this before.
and I think that ties into the previous conversation in this room, which I think most of you were here for. But you know, I was going to ask a question at the very end, which is how do you make this recurse? Which is like it's very logical to think about. I want to have, you know, an overlay at the top level that basically says, I want the following policy and the following service chains to apply at this overlay. It gets turned into an underlay packet. The underlay packet looks at it and says, well, on the physical underlay, I now